Hey guys, uh, welcome to second quarter, week one, and for this week is just a fraction review. So this is just a refresher to some of you. Some of you guys know this already, but some don't know what fractions are. And this is a quick run-up review on what are fraction and what we can do with them. So first of all, what does fraction look like? Well, fraction looks like a number on the top, and then there's a fraction bar, and then a number in the bottom. We can also write fraction horizontally. We can have the top number becomes the left number, and then instead of a fraction bar, we do a backslash, and then the bottom number is now the right number. Now, how do we say them? How do we say fraction? How do we read them? An example is the 1 fraction bar 2 on the bottom. We read them as 1 over 2. 1 is the top number, over is the fraction bar, and 2 is the bottom number. Okay? So we can also have fraction in Nemet Braille. Nemet Braille, if you guys didn't know, is a type of Braille that is used in math. So in Nemet Braille fraction, we have an opening fraction indicator as shown in this symbol, and a backslash diagonal line or slash is this. Oh, it's a slash, not a backslash. My bad. Anyway, it's a slash, not a backslash. So go over the previous slide. It's not backslash, it's a slash. And then a fraction, closing fraction indicator. So how do we write fraction in Nemet? Well, let's say we have 2 over 3. How we're going to type that in Braille is we're going to first put the opening fraction indicator, then the top number, then the diagonal line or slash, then the bottom number, afterwards, finally, the closing fraction indicator. That's how you write fraction in Nemet Braille. Now let's talk about the next slide, parts of a fraction. So I keep talking about the top number, the bottom number, the left number, or the right number, but they actually have names. The top number or left number, were, depending on the way you write it, is called the numerator. And the bottom number or the right number, again, depending on how you're writing your fraction, is called the denominator. Okay, now so instead of top number and bottom number, I'm now gonna say numerator or denominator. Moving on, so we learned about parts of fraction. Now let's talk about types of fraction. So the first type of fraction is proper fraction. So what are proper fraction? They're basically fraction where the denominator is greater than the numerator. Again, let's talk about that. The bottom number of the fraction will be bigger than the top number. So an example of that is 1 over 2. 2 is bigger than 1, that's why it's a proper fraction. 3 over 8 is also called a proper fraction. Now, since there's a proper fraction, there should also be improper fraction. So what are improper fraction? They're basically the opposite of proper fraction. The numerator is greater than or equal to the denominator. So it's not just bigger than. So the top number is not just bigger than the bottom number, it can also be equal. So an example of that is 7 over 4. 7 is larger than 4. And another example is 5 over 5. 5 is equal to 5, which is the bottom number. So those are called improper fraction. Some of you guys didn't know that. Now, let's talk about what does fraction looks like. What does the fraction tell us actually? What do they mean? So let's have an example. 3 over 8. Before we talk about the picture, let's talk about what does the denominator and numerator does. The denominator tells how many parts we're breaking up a whole into. Okay, so denominator tells us how are we going to slice a whole into, and these parts are equal parts. Okay, they're not one is bigger than the other, they're all the same size when we're talking about parts. And then the numerator tells us how many we're actually selecting out of those parts that we cut based on our denominator. Now going back, 3 over 8 shows us a picture. Now imagine a pizza, right? 3 over 8 tells us that the pizza is cut into 8 slices. The 8 in the denominator tells us that we're cutting the pizza into 8 slices. And what does the numerator tell us? The numerator tells us that out of the 8 pizza, 3 you selected 3 slices. Okay, so that's what 3 over 8 looks like. So if you have everyday objects in your house, you can do this. Okay, now let's talk about other fractions. So what does 4 out of 4 tells us in the picture? Again, the denominator 4 tells us that we're going to cut an object into 4 pieces. So again, let's talk about a pizza. So a pizza is now cut into 4 slices. And then the numerator 4 tells us that out of that 4 slices, we're getting 4 slices. So in actuality, we're getting the whole thing. Because when you cut something into parts and then you get all the parts, you're basically getting everything. So I'm going off topic, but 5 over 5 or any 4 over 4 or 5 over 5 or anything over itself is just 1. We'll talk about that later, but that's a good thing to keep in mind. Now, how about improper fraction? Improper fraction looks tricky, right? But let me ask you guys a question. In 7 over 3, that's our improper fraction, how many pieces are we cutting the circle into? Some of you might say 7, some of you might say 3. But what's the correct answer? 3. Why? Because that's the denominator. The denominator always tells us that we're going to cut that pizza into 3 slices. Not 7. The 7 tells us how many we're selecting. 3 is the one we want. 3 tells us what to do. So we're going to cut a circle into 3. Okay, now what? Well, the numerator tells us that we're going to get 7 slices. So now imagine you have 1 pizza and it's cut into 3. Can you get 7 slices out of that 3 slices? That's impossible. So what do? Well, we're going to have another pizza. Okay? Now here's the question. On that second pizza, how are we going to cut the circle? How are we going to cut the pizza? Some of you might say 4, some of you might say 3. What's the correct answer? 3. Okay, you guys might be tempted to cut the pizza into 4 because that's how many pieces we need, but that's an incorrect way of thought, because again the denominator tells us that we're going to cut always tells us that we're going to cut the pizza no matter what into 3 slices. So our second pizza will be cut into 3 slices also. Now let's critical think. Now that we have 2 pizza and it's cut into 3 slices each, do we have enough slices for 7 slices? Now let's try counting. 1, 2, 3, that's 1 pizza. 4, 5, 6, that's the second pizza. Are they enough to cover 7 slices? No. So we need another pizza. Now question, how many slices are we cutting this pizza into? 3. Again, the denominator always tells us that we're going to cut that pizza no matter what into 3 slices. So let's have another pizza. Now, let's critical think. How many slices are we getting? Now let's select 7 slices. We shade 1 slice, get 1 slice, get 1 slice, get 1, and then that's 1 pizza. Get 1 slice, get 1 slice, and get 1 slice, and that's your second pizza. And then the last pizza, we only shade 1 part, because that's the total 7 slices. So 7 over 3 looks like 3 slices of pizza cut into 3, and we're selecting 7 slices out of them. Now let's talk about fraction parts, facts, not parts, facts. So fraction facts are really helpful for learning fraction. Why? We'll get into that later, but let's talk about the fraction facts. So the first fact is any fraction that is a number over itself is equal to 1. So what do I mean by that? 7 over 7, a number 7 over itself 7 should be equal to 1. Why is that, you might wonder? Well, 7 over 7 is basically 7 divided by 7. 7 divided by 7 is equal to 1. That's why 7 over 7 is equal to 1. Now let's talk about the second fact. Any fraction that is a number over 1 is equal to the numerator. What do I mean by that? Let's talk about it again. 7 over 1, a number 7 over 1 should be equal to the numerator, which was 7. 7 over 1 is equal to 7. Why? You may ask again. 7 over 1 is 7 divided by 1. 7 divided by 1 should give you guys 7. That's basic division. Now, it's not a fraction review if we don't talk about mixed fractions. What is mixed fraction? Mixed fraction is something that is greater than 1 and it has both a whole number and a fraction part. Okay? The fraction part of the mixed number is always a proper fraction. So an example of a mixed number is 2 and 2/3. 2 is your whole number and 2/3 is your fraction part. So where are mixed fraction mostly used at? Well, it's mostly used in real life scenarios when you look at the recipes read the recipes, but the thing is, it's not really useful during arithmetic. This, uh, to tell you guys the truth, mixed fraction made me hate fraction, but fraction is actually really good. It's like it's really fun doing fraction, except when you deal with a mixed fraction, because that's a whole lot of thing that's it's horrible. But I got used to it. Hopefully, you will get used to it too. Now, mixed fraction is also in Nemeth Braille. So we have an opening mixed fraction indicator, a closing mixed fraction indicator, also as shown in this symbol. So let's have the previous example. 2 and 2/3 is number indicator for Nemeth Braille, the number symbol, the opening mixed fraction indicator, the number indicator for 2, slash indicator, indicator for 3, symbol for 3, and then closing mixed fraction indicator on the very end. So that's how you put mixed fraction in Nemeth Braille. Now moving on, we have, now let's talk about the relationship between mixed number versus improper fraction. Now going back 3 slides ago, we talked about improper fraction in pictures, if you recall. So the picture has, again, 3 circles, each divided by into 3 slices, and we shaded 7 slices. This is called 7/3. Now, going back, we're going to use the same picture. If you recall, two pizza is completely shaded, right? Yes or no? Yes. We shaded the 2 complete whole pizza. Those 2, and we talked about this previously, but what do we get when we slice something and then we shaded all of it? We get 1. Since we have 2 pizza that is shaded, every 2 circles that is shaded, we shaded the whole thing. That means we have the value 2. This 2 circles is 2. Now going to the last circle, we shaded 1/3 of the pizza, right? So this picture, or those 3 circles, is also can be written as 2 and 1/3. But wait, that we talked about those 3 circles as 7/3, right? So what does this tells us? Well, it tells us that 2 and 1/3 is equal to 7/3. These, those, that mixed number and that improper fraction is the same thing, because they represent the same value. Now let's have another example. If you guys didn't get it, we have a picture. Now imagine this: we have 2 whole pizza. Both of them is cut into 4, and then we have 1/4 slice of pizza. Now my question is, what is the mixed number and the improper fraction that are represented in the picture? Let's talk about the mixed number. We have 2 whole pizza, right? So we already know the whole number, the mixed number, 2. And the fraction part is the remaining slice, which is 1/4. So this 2 pizza and 1/4 slice is 2 and 1/4. Now let's talk about the improper fraction. Now there's two ways to tackle this. You can talk about the denominator first, or you can talk about the numerator first. In this case, I would like to talk about the numerator. So the numerator is how many slices are there present. We selected, so we're basically counting all the pizza slices. So we have 1, 2, 3, 4 from the first pizza, 5, 6, 7, 8 from the second pizza, and then 9. That's the last slice of pizza. So our numerator is 9. How about the denominator? So when we're dealing with denominator, we only want to focus on one pizza. It doesn't have to be a particular pizza. It just have to be a pizza that is a whole pizza. Now we focus on the first pizza. The first pizza is cut into how many slices? 4 slices. So that means our denominator is 4. Again, recall what's the denominator definition? Definition of a denominator is it tells us how many parts we're breaking up a whole into. So we only need to focus on one whole. We don't need to focus on on 2 wholes. We only need one whole. Okay. Anyway, we talked about the relationship between mixed and improper. Now, let's talk about changing mixed number to improper fraction. Let's say we have a mixed number, 3 and 1/5. There's 3 steps to change mixed number to improper fraction. First is multiply. Multiply the whole number and the denominator. So we get 3 times 5 is equals to 15. Second step, add the numerator and the number you got from step 1, which was 15. So we get 15 plus 1 is equals to 16. The denominator, step 3, denominator stays the same, but your new numerator is from step 2. So our new improper fraction is 16 over 5. So a good way to memorize how we're changing mixed to improper is using the acronym MAD, M-A-D, multiply, add, denominator stays the same. So make mixed numbers add, makes mixed number MAD by changing them into improper fraction. If we can go from mixed to improper, can we go the other way? Can we go from improper to mixed? And the answer is yes. Yes, we can. So let's start with our improper fraction, 16 over 5. So we have 4 steps on doing this one. So first step is we go divide the numerator and with the denominator. So we do 16 divided by 5. Note that we're going to use remainder, so don't use decimals. We're just going to deal with remainders when we're dealing with this step. It's very important, okay? So 16 divided by 5 should give you guys 3 with the remainder of 1. Now, second step is we're going to let the quotient or leave the quotient as your whole number. So the 3 is your whole number. because that's your quotient. Step 3 is always put the remainder as your new numerator. So your remainder becomes your numerator, and then step 4, denominator stays the same. So our new mixed number is 3 and 1 over 5. A good way to memorize this is the word glad. Again, we're using the acronyms. G is go divide, 2 is leave your quotient as your whole number, 3 is always uh, A is always put the remainder as the new numerator, and D, denominator stays the same. Make improper fraction glad by changing them into mixed number. My sentence is really bonkers, but hopefully you get the idea. Now, for the last slide, whether we go from mixed number to improper fraction or vice versa, our denominator will always stay the same. So that's the one thing you can count on that will not change, is your denominator. As you can see, when we go 16 over 5 to 3 and 1/5, 3 and 1 over 5, our denominator stays 5. We don't do anything. Same thing with 2 and 1/4 and 9 over 4. They're all 4. And going a bit farther back, we have 7 over 3, and we have 2 and 1 over 3. They all share the same denominator, which is 3. So that's basically it. Our denominator stays the same. And that's the end of the video. Have a great lesson. See you in the next video. Don't forget to click and subscribe, whatever. Goodbye.